All right. Okay, here we go. Notes out. Today is going to be today is going to be a bit of a leap from what we've done so far. So the trick here will be figuring out how to take what we've learned so far and kind of apply it to something sort of new, sort of different, sort of something else. So first, all right, so in your notes, start maybe a new page. This isn't necessarily a new section, but this is still ionic bonding, but this is a new thing. So find some real estate in your notebook. You're going to need at least a page, if not two, to get through the stuff that we're going to do here throughout the hour. So polyatomic ions is what this is called, but we're going to start with a review, something that we've done before. So the first thing we're going to start with is a question like this, where we add two elements together. One of them is a metal, one of them is a nonmetal, so we're going to form a cation on the left and an anion on the right. And we need to determine what this is going to look like. And so again, you're going to want your periodic tables out with your notes in the top of them, what are in what columns and whatnot. So let's start by finding potassium on your periodic table. Find potassium. And again, it's going to be on the left. It's a metal. Find potassium. This is one of the ones that kind of is a totally different letter than what you'd expect for something like potassium. Okay, good. Okay? Okay. So I want you to write this in your notes just like I'm doing it here. Okay. Since we're talking about ionic bonding, what kind of ion is potassium going to form? What's the number up at the top of the column where you found potassium in your periodic table? +1. Let's do the same drill for oxygen. Find oxygen on your periodic table. Find the column that it's in. And then find that number that we wrote what seems like a month ago, but I promise you it was just a week ago. What number? -2. Okay? So that's easy enough. Next, we are going to do the dot diagram for these two ions. The one for potassium is pretty easy. What's potassium going to look like? What's the dot notation here? Just 1. How do you know it's just 1? What about the ion tells you that it's going to have just 1 dot? How do you know? The +1. What does the +1 mean? Adding 1. Hold on. Yeah, what's potassium trying to do? Trying to give it away, right? So if it gives away that electron, it's going to end up becoming a +1. So its dot notation is just a single dot. Well, what about oxygen? What's the dot notation going to look like for oxygen? Why 6?
Oh, yeah.
You're right.
Yeah.
Why 6, though?
They need 6 to create like the shell. So yeah. Or they need 2 to create the shell.
Yeah, so it needs 2. It needs 2 to get to 8, which means it's going to start with how many dots? 6. Dot notation for oxygen is just going to be 6 dots. Okay, so when we combine these, we make an ionic bond with this particular combination. Does this work out even? 1 potassium and 1 oxygen?
No.
Why not?
Need 1 more potassium.
Why? I agree, but why? Yeah, so how many does oxygen need? Needs 2, but each potassium can only give away how many? Just 1. So potassium has to phone a friend. This dot goes here, this dot goes here. And now the million-dollar question, what would this chemical formula look like? K, K2O. Right? Because we needed 2 potassiums. We have just 1 oxygen. This worked out. So, spoiler alert, this whole thing here, I know it's kind of in the way, move this. This is what you're going to need to be able to do on your own Thursday for the quiz. There'll be a handful of problems just like this with different bits and pieces. Maybe it'll be lithium and sulfur, or magnesium and chlorine, or whatever. This will be the extent of the quiz on Thursdays. Putting together pairs of, in this case, metals and nonmetals, and figuring out what that combination will look like. That'll look just like the worksheet from, was it Friday? Did we do a worksheet on Friday?
I remember.
I don't either. It's like 3 weeks ago. Okay, so next we have a vocab word. You're going to want to write all this down in your notes. Polyatomic ions. These are just like the ions we've been talking about, with the exception that polyatomic ions, the poly meaning many, and atomic meaning atoms, polyatomic ions themselves have more than one atom in a unit. Cation or anion made of more than one atom. The example I put up here is nitrate. NO3 with a -1 charge. So again, it looks kind of similar to what we had for oxygen or lithium or sodium or any other kind of thing, where it's got that little -1 on the top right. So what we're going to do next is a problem just like the first one we did together with potassium and oxygen. But this time, we're going to use a polyatomic ion, wherein before we had used oxygen instead. So under this definition, and just like the first one we did, let's do sodium plus nitrate. So write the ion for sodium, write the dot notation for sodium below it, write down that ion notation for nitrate, which we just did in our definition, and then we're also going to do a dot notation for the nitrate. And again, this is where it's going to be kind of the same, but it might look a little weird. Sodium plus nitrate. So let's get the easy stuff out of the way. Sodium, what ion is that going to make? Find it on your periodic table. It's a metal. It's going to be on the left. What's your periodic table, bro? You need a loaner for today, get you through?
Yeah.
You know, I'm here to help, bro.
I need one. It doesn't have all the colors and stuff.
It doesn't have the colors.
Kind of boring.
That one's at home, right?
Yeah.
For safekeeping. Keep it at home. What could possibly go wrong with it, you know? It's probably handy yesterday we had our snow day. Dang it. All right, so where's sodium? On the left. What group is it in? Alkali metals, good. What's its charge going to be? Na +1. Okay? Easy enough. While we're here, let's do the dot notation for sodium. Let's get it out of the way. What's that going to look like? 1 dot. Good? Ooh, nitrate. So what is this going to look like? What's the ion symbol going to be for this one? And it should be right there in your notes. We wrote it a second ago. What's that going to be? NO3 with with a -1 on it. What about the dot notation for a polyatomic ion like this? What's that going to look like? How many dots will this have? And I want you to consider and think of this nitrate just like you would an oxygen ion or a chlorine ion or a bromine ion or any of the other ions that we were using last week. So if this was chlorine -1, how many dots would it have? If it was chlorine. Chlorine's a -1, it's one of the halogens. How many dots would you put around chlorine? 7. Why? Well, what does the -1 mean? It needs one. It needs one, right? Well, basically, nitrate also needs just one, right? Based on the charge of it, it's looking for one electron. So we're going to do something here that isn't exactly strictly chemically legal, but you know I've never been one to follow rules. I know. Breaking rules. On video, no less. Let's go. So let's consider this ion the same way we would consider any other anion. Chlorine or bromine or anything in that same family. It has 7. So does this work out? We get these two together? What does sodium want to do with this one electron? Get rid of it. What is nitrate looking for? Just one. Does anybody have to phone a friend here? No. So how would we write this chemical formula? And it really is as easy as you're thinking. Josh, come on.
NaNO3.
Oh my goodness. This kid sciences. That is sodium nitrate. We didn't have to do anything. We have one package for sodium, one atom. And in this case, the nitrate is a package deal. That NO3 is a thing unto itself. And we only need one of those packages to make this work. Each sodium's giving away one. Each nitrate is taking one. Great. Sodium nitrate. Let's make it weird. So let's start this one, just like we just did the other one. Find calcium. The nitrate side is going to look just like the other question, but this one is going to be a little different. Come on in, bro. You had all day yesterday to rest, man. Did you peel off a nap yesterday like I did?
No,
Bro. Calcium plus nitrate. Indeed.
that's a cool little setup you got there.
I know, right? Fancy. All right, calcium. What's calcium going to look like? Where was it on the periodic table? Plus 2. Where was it on the periodic table? What group? Alkaline earth metals. Good. Group 2, it's going to be a +2. What's the dot notation going to look like then for this? 2 dots. If it's a +2, what is it trying to do? Get rid of 2 electrons. Well, nitrate, we don't really have to think about this because we literally just did it, right? So what is the ion notation going to look like for this? Plus what? And what would we use for dots here for thinking about nitrate as all one thing? We just did it above here. How many dots? 7, because what's it trying to get? Just one. I'm going to rewrite this, NO3. 7. Does this work out like the last one did? Does this work out even? Well, calcium's trying to give away 2, but each nitrate can only take how many electrons? Just 1. So what are we going to have to do here? Phone a friend. Who needs a friend here, though? Calcium or nitrate? Nitrate, right? Calcium's got 2. Nitrate can only take 1. So if we give 1 away, this isn't quite perfect. So somebody needs to phone a friend, and in this case, it's our nitrate bro. And now what can we do with this extra electron? Now I want you to consider how we're going to write the formula for this, given the pieces we have here. And I also want you to think about the drill we did, seems like forever ago. When we were looking at chemical formulas, we were trying to count how many atoms were in a chemical formula. There was something we did in there when we were counting atoms that kind of applies to this. And I want you to keep in mind, we're going to keep that package, that polyatomic ion. We want to keep that ion together. We don't want to break it up. We want to count it like it is. But we want to make sure we get the quantity correct. So let's do the easy part first. What about calcium? How many calciums we got? Just 1, so that part's going to be easy, right? Do we need a number after the calcium? No, because we just have 1. How are we going to do the nitrate, though? How are we going to represent that in this formula? Anybody want to take a guess? Write it down on your page if you want to attempt this. What do we do here? Okay, you're almost there. We need to somehow show both of those nitrates. No, you're going to have to wait, bro. Oh, you're so close. So close. You're almost there. Don't feel bad. St. Jean messed this one up too.
Close. It's close. That's what I did too.
Yeah. Yes, it's exactly what St. Jean did. Don't erase that part. You had that part right. Put that part back in. Yes, put that back in there. Nope, I see what you're thinking there, but you want to keep that NO3 the same. You don't want to adjust the NO3 at all.
Order of operation. How would you?
You're so close. Come on. Come on.
Wait.
Don't put it there. Don't put it there. Don't put it there.
Then where?
Where is the question? Josh, come on.
Dude, I am lost.
Come on.
Boom. I got it right.
Uh-oh.
He told me I got it right.
Close.
I don't know if I don't know how good I feel. Oh, you're close. No. All right. So many of you stumbled into the right thing here. We don't want to mess with this NO3. We want to leave that nitrate together. Right? Some of you figured out if we want to leave something alone and leave it together, we encapsulate it. We surround it with some parentheses. But how now do we represent 2 of them? Where would the 2 go?
On the outside.
On the outside, yes. Where, though? There's
On the right.
front, back. Okay, keep going. On the right.
Bottom.
The top or the bottom? What have we been using for the top? What have those numbers represented when we're putting numbers at the top? What were they representing?
Like if there's
Well, hold on. Before we get there. What are the numbers at the top representing?
the electrons.
Yeah, charges and electrons, right? These are how we denote ions. Well, we don't want that now. We want to count them now. Remember that worksheet we did with all the ones that we had to count up how many things? You were doing PEMDAS and the distributive property. Remember this? St. Jean?
That's what I said.
I know.
Also, you do +2 in the top right.
Not +2. We just want to count 2 NO3s. Where should it go?
At the bottom.
It should turn on.
That's what I said first.
Did you though? I'm pretty sure you said the top.
He said at the top. I said at the bottom first.
I said the bottom. You said the top.
Yeah, sure.
Yeah. Well, you know what? It's on film. We'll run it back. We'll see exactly who said what. We will see who said what. So this is how you're going to denote multiples of a polyatomic ion. You're going to put it into parentheses. If you need an extra, if the phone a friend part of this ends up being, hey, we need extra of those polyatomic ions, 1, 2, 3, 7, however many we need. You're going to put that into parentheses. and you'll put the quantity for the thing. We needed 2 of these to make this work. So you put the nitrate in parentheses, and you add a 2 in this case because we needed 2. Back up here, we didn't have to do anything. That first one, we just left it alone, right? Because there was just one of them. But if you need a quantity of the polyatomic ion, parentheses are how you are going to get there and how you're going to notate it. So let's keep turning this thing up. I'm going to hand out a sheet. This is, well, if you want to put this in your notebook, that's fine. Given the propensity many of you have to have things in your notebook evaporate, I will hand these out. So when we do tests or quizzes or whatever, you will always get a copy of this. But if you want to take this home, put it on the fridge, show friends and family members that you know how to read a horrible, complicated chart like this, go for it. Okay, so look at this orange sheet. We are only going to use this middle part. The top and bottom you can ignore. So we're only going to use the middle. And what this lists out is a bunch of different polyatomic ions. You don't have to memorize these like your periodic table. You don't have to memorize the periodic table. You don't have to memorize this whole list of polyatomic ions either. How you spot them. What's the ending of most elements? What's the last 3 letters of most of the elements? IUM, chromium, sodium, aluminum. Is that it? Just those 3? Or nitrogen or oxygen, the ending of the atoms and elements all sounds one way. If it ends with 8, like you see here, chromate, like you saw in the examples we did before, nitrate, that's kind of your alert. Yes, sir. Yeah, that's it. Don't show anybody else. Don't show, especially
I don't need to see it. I probably.
anybody else.
Yeah, again, you're not cool. Yeah.
So use this middle part like you use your periodic table. Find the metal on your left, and then use this middle part to find that polyatomic ion named chromate. And you're going to do the same drill like we did before. Make sure you get the symbol for lithium right. You're close. You're close. Do the same. I know it's a pain, climber, drawing all these dots and doing everything else.
This is making me not want a science anymore.
You wanted to science before?
Yeah, I wanted to science.
And this is what broke you, polyatomic ions? Yes, yeah. Well, remember, we're focused on this. The -2 tells us how many dots it's going to have. Right? Don't worry about the O4 or the O3 or any of that. Worry about the overall charge of the polyatomic ion. That's what will show you what you're looking for. Is this us?
Yeah, I'm doing that.
Okay.
And then lithium
Good.
is 3, right?
What? Get out your loner periodic table. It's definitely not 3.
Can I say hi to the video?
No.
Hi, video.
No. I'm going to have to edit that out. Okay? Yes, get rid of this though. Because remember, once they get together, we no longer have the charges. Once they've traded and formed a compound, we don't have the charges anymore. All right, where's lithium? Alkali metals. What's the charge on the ion for lithium? +1. Did anybody find chromate on your orange sheet? Chromate, which it's 4 down, I think. 3rd one down. Cr04. What's the charge on chromate? Okay, so dot notation. What's lithium going to look like? How many dots? Li with a single dot. How about chromate? What's chromate going to look like?
6 dots.
6 dots. How do we know that? Because it needs to. Okay, so in this case, how does our situation work out? Are we even? We good to go? No, why not? We need another something. Who's phoning a friend here? Yeah, lithium. We need an extra electron for chromates, looking for 2. So, lithium phones a friend. Okay, what will this formula look like? All right, now hold on. Do we need parentheses, though?
No.
Right, yeah, because how many chromates do we need? We only need 1. So we need the 2 Li's, but then the CrO4 we can leave all alone. Lithium, chromate, it is. All right, you're on your own with this one. Where's your periodic table, bro?
Dude, it's in here, but I remember stuff. I know the table.
All right. Well, I mean, it sounds like you have a good idea on magnesium, but I would just glance at this just in case. Oh.
I got my colors in here.
Please don't. If you open that up, it might explode papers out from who knows where. It's probably best if you just use the loaner.
What?
Good. So again, you're looking on your orange sheet to find sulfate. You're looking on your periodic table, in this case, to find magnesium.
You got all this,
Addy, quit picking on Cam.
Yeah, real. I didn't do anything.
You got this all written down? You got to figure it
Throwing
out?
stuff at me. What the heck?
Oh my gosh.
Did I throw something at her?
Just it might have been something that fell out of this bag when he opened it. Okay, where's sulfate at though? Just check sulfate.
Oh, SO4.
Yes. But yeah, that's it though. Yep, you got it. So be careful with this orange sheet. A lot of these look almost identical to other ones. Check this one. This would be perfect, but I don't find magnesium. Yes, so.
Oh, you would.
Yes. So you're right. It's +2, but what does that mean? Perfect. Nice job. Yep. This one's pretty easy, right? All right, speed run. Magnesium. What's it look like? What ion? +2. What's the dots for that? 2. What about sulfate? SO4, what's the charge on sulfate? -2, how many dots? All right, how's this work out? Are we even? Okay, so magnesium is going to donate its 2 electrons. Do we need to phone a friend here at all? No, we're good. So how do we write that? And we're done. Last one. Get this. And then you will all be experts at this. Potassium phosphate.
Climber, you do like an outro on your YouTube video?
What's that?
Like an outro or you do an outro?
We could. I got subscription to one of the music services, so we could put some beats on it or
You should make a montage.
a montage.
Science montage.
My channel, which I'm gonna upload this to and post in the classroom, there's like 30 videos in there. Yeah. Look at you doing science. Stop it. Stop it. God. You have any idea how long post-processing takes? Editing those little things out? I know. Just run it at like 2x. Just run it at 2x speed is probably for the best.
On TikTok.
Yeah, it's for everybody that missed the lecture. It's for you to study for your quiz and your test. See what I did there?
I'm confident.
Are you?
I did it.
You did it in your mind? In your mind? All right, nice job. Getting there. Okay, so where is the dots and stuff for this one? So where's K? Show me K. Show me where K was on the periodic table.
It's the.
Okay, so how many dots will it have?
It's plus, so it's just got one.
Okay, and where did you find this?
Phosphate is here.
What's the charge?
It's -3.
Okay, so what's that mean?
So it's got a 5, right?
Yes? So is one of these going to be enough?
No.
Is two of those going to be enough?
No, I don't think so.
No? So get the ratio right. You got it. That's it. Yep. And then how do you write that? Yes. Yes. Nice job. But which one has 3, Alex? Yes. Yes. All right. Nice job. Potassium, where's it at? What's the charge? +1. What about phosphate? -3. So what's this going to end up looking like? Single dot, PO4, 2, 3, 4, 5. Yeah, we're going to need 3 phone a friends here, right?
Yeah. That's a lot.
We are going to do more practice with this tomorrow.